Chapter 8. This is going to be a fun one. This is probably the one that I'm most excited for, and this is basic trigonometry. And I like this because trigonometry is fun in and of itself. Because it's this geometry we've been doing, but it also goes more towards the math and numbers rather than the diagrams and stuff like that. And for this trigonometry, I want to remind you of the Pythagorean theorem. The c equals the square root of a squared plus b squared, right? C equals square root of a squared plus b squared. And I refuse to say a squared plus b squared equals c squared, because that means nothing, right? It just looks pretty. This will give you your real answer. No one wants their answer squared, but I digress. But in the Pythagorean theorem here, you are finding another part of a triangle given two pieces of a triangle, and that's exactly what sine, cosine, and tangent do. This will solve for the hypotenuse given two legs, or you can change it around a bit and solve for a leg given a hypotenuse and a leg, right? So all we'll be doing with sine, cosine, tangent is solving for another side given one side and an angle, or solving for an angle given two sides and given two sides. But before we can get into that, I want to remind you of two, not remind you, but kind of get two very simple basic concepts down. First is the opposite, adjacent, and hypotenuse. The opposite, adjacent, and hypotenuse, and how to label them on a triangle. So if we have a triangle here, very important that this is a right triangle, and we'll only be dealing with right triangles for right now. But let's say we're dealing with this angle here. We want to look at that angle. And usually when you have an angle that you're looking at, but you don't know its measure, you just call it theta, which looks like a zero with a line through it like that. We call that angle theta. It's like x for a number that you don't know. Theta is the angle that you don't know. So if we have theta here, there are three sides. First is the hypotenuse. You already know because it's the longest side and it's directly across from the 90-degree angle. So this is the hypotenuse. Hypotenuse, I don't know how to spell hypotenuse, but that's the hypotenuse, this side right here. Then we have the adjacent and the opposite. And when regarding this angle right here, this side is touching this angle. It's built on this angle, so we call it adjacent. It's adjacent to the angle, right? Adjacent. And then because this never touches the angle in question, it's across from it, just like the 90 is from the hypotenuse. This is opposite, like that. And same thing here, if we were to, where did I put the eraser? Right here. Same thing, if we were to move theta, the angle that we're looking at, move it from this bottom corner there to this top corner up here, we'll call that theta. Well, then this is still the hypotenuse, right? That's still the hypotenuse, but now because this side touches theta, this is the adjacent, and because this one is opposite, this one doesn't touch it, we call this opposite. And then same thing, you can spin this triangle, flip it however you want. You're still going to label it based on which side touches theta and which side doesn't touch theta. And then the hypotenuse, as you already know. And I'm not going to go over that and give examples, because it's it's pretty easy to understand once you see it once or twice. But from there, we're going to move on to angle. We're going to move on to scale factor. So just like in the previous video where we talked about scaling up a shape, if we have this triangle here, right, call it a 90-degree triangle, and we'll label this X, Y, and Z like that, and then we'll call this theta. So the opposite is Y and the adjacent is X. Z is the hypotenuse. And if we scale this by some scale factor, doesn't matter, just call it K. This is the new triangle. So this would be K times X. This would be K times Y. And this would be K times Z. And then theta stays the same because we're just making the lines longer. We're not changing the angle at all or their orientation, right? It's not like this goes from being a 90-degree triangle to a 180-degree triangle if we our scale factors 2. So that all stays the same, but like this. Now, what if I wanted to take the ratio between the opposite to the adjacent, the opposite over the adjacent? Well, that would just be y over x, right? Depending on whatever y and x equal, that would be your answer. Same thing over here. We would do ky over kx. But we can actually simplify this down a bit because we have k multiplied on both the top and the bottom. We can cancel out k, and then that just goes to y over x. Same thing as right here. So the ratio between two sides is always going to be the same, right? The ratio between the two sides is always going to be the same. And to prove this, I'll give an example here. If we say that x, y, and z are the 3, 4, 5 triangle that everyone memorizes, right? 3, 4, 5. And what if we triple this triangle? Triple all the lengths. So multiply by 3. If k equals 3, 3 times x, or 3 times 3 is 9. Right, so that goes to 9. 4 times 3 is 12. And 4 times 5, or 3 times 5, sorry, is 15. Like that. Now, theta is going to stay the same, but if we look at this, if we take the opposite over the adjacent, that gives us 4 thirds like that. And then if we take 12 over 9, well, we simplify that out, right? We can divide both of those. 3 goes into each of those. 3, 6, 9, 3, 6, 9, 12. And then 12 over 9, if we divide each by 3, that equals 4 thirds. So the ratio will always be the same if you have that scale factor, right? And now we have fancy names for these ratios, these sine, cosine, and tangent, right? So let me show you the sine. So if we take the sine, and if you look on your calculator, and I don't know if you're going to be able to see this, but there's a sine button right there, cosine and tangent right there, like that. If you press those and then type in your angle, so if we have the sine of theta, right, whatever our theta is, that is always going to be equal to the opposite over the hypotenuse. Every time, that angle is always the same as the opposite over the hypotenuse. right? So next we have the tangent, or not the tangent, I'm sorry, the cosine. The cosine of theta, the cosine of theta is always equal to the adjacent over the hypotenuse. Adjacent over hypotenuse every time on your triangle. And the one we were looking at earlier, the tangent of your theta, is always every time equal to the opposite over the adjacent. I apologize. Always equal to the opposite over the adjacent. And there are more. There's, arcsine, arccosine, arctangent, secant, cosecant, cotangent. There's more, but these three are really the foundation, all that you need to know in geometry. Now, if you do end up taking a trigonometry course, you are going to have to know all of that. I would also like to mention that this only works for right triangles. Now, I don't know if they teach it in calculus or pre-calculus, whenever they teach it. They may teach it in trigonometry, and pre-calculus is just to give more teachers more jobs, because that's just algebra 2 and trigonometry put in one class together. But I went off on a tangent there. I'm hilarious. But no, you can do this with other triangles, other triangle types. They just you just don't use these. You have to alter them, use different trigonometric identities and all kinds of stuff. But I'm not going to get into that in this video. We're just going to stick to sine, cosine, tangent. Like that. So let me show you. We'll go through a couple examples here. Oh, I shut the light off. Not that it matters for you guys very much. So, I also forgot to mention an easy way to remember this. I don't know if you've heard before, SOHCAHTOA, SOACHTOA. I don't know, that might help you. It doesn't really help me, but it stands for sine opposite hypotenuse. So you do the sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, tangent is the opposite over the adjacent. I kind of just memorize it as opposite, adjacent, or hypotenuse, opposite, adjacent, hypotenuse. And then, it goes in that order over the hypotenuse, and then tangent is just opposite, adjacent. But I don't know. If it helps you, more power to you. Okay. From here, that's nothing. Okay. Chapter 8, practice. So I'll give you a couple practice problems here. We'll start with this triangle. I'll show you how to use these new ratios that you've learned. So if we say this right here is 40 degrees, and this up here, x, and this is 12 units, like that, and I ask for you to solve for x, right? Well, usually you could solve for x if you had the hypotenuse, but now instead of the hypotenuse, we have this right here. And you know what? I'm going to write up here in the corner our thing. So we have the sine is the opposite over the hypotenuse. The cosine is the adjacent over hypotenuse, and the tangent is the opposite over adjacent. Like that. Now, if we come back here and look at this, well, this is going to be our theta right here. So we are working with the adjacent, the opposite, and theta. Now, which one up here works with adjacent, opposite, and theta? Well, that has the hypotenuse, so it doesn't work, so we can't use the sine. Cosine also has hypotenuse, so it doesn't work. We can't use cosine. But tangent has theta, opposite, and adjacent. So we're going to use theta, or tangent here, sorry. So we want to take our tangent, right, of our angle, 40 degrees. 40 degrees like that. And when plugging this into your calculator, and I'll say this again later, make sure your calculator is in degrees. I know most of these TI-84s come preset to radian, because radian is far superior to degrees. But regardless, I'll show you how to do that here in a second. So if we have the tangent of 40 degrees is equal to the opposite, x, equal to the opposite over the adjacent, 12. Like that. And now we just have some basic algebra we can solve. Right? So the tangent goes to, well, first we can just bring the 12 over, right? By multiplying by 12 here times tangent of 40 degrees equals x. And now we can just type this into the calculator, right? And let me show you how to change that over. So, all right. You want to press here, mode right here next to the second button. It'll take you to that screen. And you want to scroll down to where it says radian and degree. Mine's in radian right now because I use it for radian. But you want to scroll over if yours is in radian to highlight the degree, and then come down here, press enter, and then it'll move it over like that. And it'll say degree. And then from there, just press second, and then mode again, and you're back to your home screen. And it will then show you, then it'll do everything in degrees instead of radian. So like this, all you have to do is type in 12 times the tangent of 40 degrees, just like that, and press enter. And it'll tell you it's that decimal 10.96, or 10.069, sorry. I was looking through the camera screen behind you. It's kind of hard to see. But usually, I mean, I tend to round this off after about three decimal places. So you could say that x equals 10.069, like that. And that would be your answer for x. So I'll go through a couple more, and then I'll have you do some on your own. Well, I mean, I guess I'll walk through them all. You can do them however you want on your own. Okay. Next, we're going to have this triangle, like this. Let me make that bigger. Got a whole wall. Don't know why I'm saving space. Okay. We'll say this here is 25 degrees. We'll call the hypotenuse 20 units, and this is y units. So from there we look. We're dealing with theta, the hypotenuse, and the opposite, right? Because y is opposite to theta. So which one has hypotenuse and opposite? If you look up there on the chart, you can see that, right? No, you can't. Well, here, I'll rewrite it down on the bottom here. Put it here. Sine theta equals opposite adjacent or over hypotenuse. The cosine See if you can do this one. Cosine adjacent over hypotenuse. Over hypotenuse. And the tangent of theta is the opposite over adjacent. Apologize, I'm going to have to start speeding up here. We're probably already at 30 minutes by now. I try to keep them all under 40, so that's not going to happen on this one, but I'll start speeding up. Okay, we have the hypotenuse and the opposite. The one that deals with hypotenuse and opposite is the sine. So we take the sine here of 25 degrees is equal to our opposite, y, over our hypotenuse, 20. First we multiply it by y over here, so we get y sine 25 equals 20. And then we just divide by this, we get y equals 20 over sine 25, like that. And then just plug that into your calculator, right? Plug in 20 over sine 25 like that. Press enter and you get 47.324. So we can say here y equals 47.324 like that, and that would be your answer for y on that one. Staples are coming out of the wall. I might have to fix that. Here in a minute. I'm not going to hang this on there anymore though. Okay. From there, our next triangle. We have triangle here like this. Call this 60 degrees, 14, and x. All right, so we have the adjacent and the hypotenuse. Make sure this is right. The adjacent and the hypotenuse. Which one has the adjacent and hypotenuse? That is the cosine. And with the cosine, we go the cosine of 60, our degrees there, equals our adjacent over the hypotenuse, x over 14. We multiply by x. We multiply by our 14 here. X like that, and we plug that in. We do 14 cosine 60 like that, and press enter, and you get 7. And for that one, you get x equals 7. Next one, here in a second. We have our triangle here. And we have, this is 7 units, this is x units, and this is 35 degrees. Like that, we're dealing with theta, the opposite, and the adjacent. One that deals with theta, opposite, and adjacent is the tangent. So we take tangent of 35 equals 7, the opposite, over x, the adjacent, like that. First we multiply by x here, so we get x tan 35 equals 7, and then we divide by tan 35, x equals 7 over tan 35, like that. And you get, I'm not going to show you the calculator, you should get it by now, 7 over tan 35 is 9.997. So x equals 9.997, or approximately 10. Okay. Next, I'll give you two more. We're not going to go through all 9 of these. Here we have triangle like this. Okay, so this is 50 degrees. This is 15, and this is x. Right here, we're dealing with the hypotenuse and the adjacent. When dealing with the hypotenuse and the adjacent, you use the cosine. So we take the cosine of 50 degrees is equal to the adjacent over the hypotenuse, 15 over x, like that. We multiply by x and bring the cosine over again, so we can kind of just swap these places. We get x equals 15 over cos 50, like that. And you plug that into your calculator and you get 19.58, right? 15 over cosine 50, and you get, not that. I did something wrong. I don't know, I was trying to go too quick, but it's all right. And I mean, hopefully you've got the point by now. I'm going to stop with the examples there because it's complicated, but if you want more examples, there's plenty of examples online on the internet that you can look up and do like that. But now, that's all I have. I thought we were going to get into the arc, sine, cosine, tangent, but apparently not. You use arc, sine, arc, cosine, arc, tangent for trying to find, like if you have both sides and you want to find theta, then you would use the arc, sine, arc, cosine, arc, tangent, and those are also buttons on your calculator. But with that, go into chapter 9. In chapter 9, let's see, I flip here to chapter 9, you will be doing similar triangles rather than congruent triangles. All right, chapter 9.